Atacama B-Mode Search project is an experiment that's trying to look for the signature of the earliest moments in the universe when we think it was full of gravitational waves, and those caused patterns in the cosmic microwave background radiation that we're searching for. We hope that at the end of the project we'll have actually discovered the signature of these gravity waves in the early universe by actually finding and measuring these elusive B-modes. The project has been in Chile for about 1.5 years, and prior to that it took about 3 years to build it. The cosmic microwave background, also known as the CMB, is the leftover radiation from the Big Bang, and it's been studied very well by satellite missions, including most recently Planck. But there are still areas that we need to study from the ground, and 2 of those areas are being studied by ACT, the Atacama Cosmology Telescope, and ABS, the Atacama B-Mode Search. After we started building ABS, we developed a relationship with the Universidad de Chile and began collaborating, and in particular I am co-advising a graduate student named Srinivasan Raghunathan.
My thesis is focused on searching the gravitational waves from the earliest stages of the universe. For my thesis I used this experiment called ABS, Atacama B-Mode Search, located at Cerro Teco in the Chilean Atacama Desert at an altitude of 5,200 meters. Yes, I feel I work on a world-class experiment because ABS is one of the first telescopes looking for these imprints of gravitational waves on CMB polarization. And if we succeed, it's going to be one of a major impact for the future science on future CMB science.
And through this collaboration with the University of Chile, Ricardo Munoz, Luis Campuzano, and Gonzalo Palma decided to look into developing something, a bigger project that would include cosmology and also bring in Princeton University as well as the University of Chile. And with that, they developed their Anillo.
En cuanto al rol del Princeton en la cosmología, es el centro mundial de mayor prestigio y sin duda el experimento que tienen en curso en Chile, del cual nosotros somos parte, también probablemente va a causar un gran impacto en la ciencia. El resultado del trabajo con los académicos de Princeton ha sido muy provechoso en este año de trabajo porque ellos tenían un experimento corriendo en Chile del cual nosotros no éramos parte y ahora sí somos parte integral del proyecto que se llama ABS.
The reason that we can do unique science with our smaller telescopes compared to ALMA is largely because of the field of view that our telescopes can have. Our telescopes can look at a large area of the sky at once, while ALMA, with amazing precision, looks at small regions of the sky at a time. And ALMA has a huge array of features that make it superior in many ways to our instruments, but it's unable to answer the questions about these cosmological questions which require you to look at a large area of sky at a time. So cosmic microwave background experiments always take place these days on special purpose telescopes that don't do any other science. They just look for the CMB. They just look at the CMB.